Hello everybody, this is Cap of Codaclysm, as you could probably tell by the banner there, and I would like to welcome you to the second video in my beginner C++ tutorial series. So the topic of this video and the next video is going to be variables, and I've split it up into two videos so that we can kind of take this first video to kind of explore the concepts of variables, and then in the next video we're going to do some actual coding. So let's start off by looking at what are variables. Variables are basically just memory locations that C++ allocates upon our request to store a data of a certain type and of a certain size depending on the data type we choose. And that's really all it is, guys. It's pretty much that simple. The stored data can be accessed, changed, and manipulated by our program, and it's really just pretty much that simple. The thing I want to get across in this video is why there are so many different data types and when you would use them. So let's look at some of the common data types in C++. We have char, short, integer, float, double, and bool. There are more, and there are variations of these, but we're just going to stick with these for the next two videos. So let's start off with a char. When you declare a char, C++ allocates 1 byte of memory to store data in. And in this 1 byte of data, you can store any lowercase, uppercase letter, as well as special characters. You can also assign integers between negative 128 and positive 127 if it is a signed char. If it is an unsigned char, you can store values between 0 and 255. So as you guys have probably guessed by now, a signed char just basically allows you to store a negative value, or really a signed integer of almost any of the types we'll look at today. Just allows you to store a negative integer. An unsigned char takes the memory that would have been used to allow you to assign a negative number and is used to allow you to assign an even larger positive number, as you can see. And something else worth noting about a char is that when you store a value into a char, you might not get back the same value, because C++ assumes that when you access a char, what you're wanting back is either a letter or a special character. So if you store, say, 97 into a char, and then you try to access it, what you're most likely to get back is the letter A. And we'll kind of go over that stuff in the coding portion of the tutorials. But let's take a second to talk about binary. So in our everyday lives, we usually use the decimal base 10 system, which uses characters 0 through 9 to represent numbers. Well, computers don't understand that. Computers understand binary, or base 2, which uses the characters 0 and 1 to represent numbers. And as I said earlier, a char allocates 1 byte of memory for us to use. And in 1 byte of memory there are 8 bits, and each bit can contain either a 1 or a 0. So the lowest binary representation of a char would be 8 zeros, and the highest would be 8 ones. The best way to think about binary is kind of like a series of light switches, and depending on the light switch's location, it represents a different, I guess you could say, decimal number for our uses. So if this one here were to be switched on or turned to 1, and the rest of these were off or 0, then the value of this byte here would be 8. And if these two were to be switched on or switched to 1 and the rest of them left off, the value of this byte would be 3. Now, I've kind of given a bit of a bigger example down here with the number 58. As you can see, we have these 4 switched on, and according to their position, they each have a different value in decimal terms. And what we do is we can just add that value up and get what the decimal representation of that binary code is. And that's about as in-depth as I'm going to go into binary in this video. If you guys would like to know a little bit more about binary, I'd be more than happy to make a separate video about that for you guys. But for now, we're going to kind of move on to shorts. So when you declare a short, C++ allocates 2 bytes of memory for us to use. And in those 2 bytes, we can store values between negative 32,768 and positive 32,767 with a signed short. With an unsigned short, we can store values between 0 and 65,535. And the binary range, as you can see here, since there are 2 bytes, would be 16 zeros for the lowest binary representation and 16 ones for the highest, which would be 16 bits or 2 bytes. And if you guys noticed here, I said that with a unsigned char, you can store values between 0 and 255. And if you add all of these here up, you get 255. So if you guys kind of make that connection there as we're going through these. But let's move on to an integer. So when you declare an integer, C++ allocates 4 bytes of space in memory for us to use. And in that space, we can store values between negative 2,147,438,648 to positive 2,147,484,647. Signed. And unsigned, we can store values between 0 and 4,294,967,259 unsigned. And the binary range for an int is, as you can see here, the lowest binary representation would be 32 zeros, which would be 32 bits or 4 bytes, and the highest would be 32 ones. So I hope you guys are kind of making the connection of why there are so many different types. It's not necessarily that there are so many different types of values to store, but the size of the values you're storing. So, for instance, if you had a program and you knew you were going to have to store a value between 0 and 500, you probably would not want to use an integer, because then you will only be using these 2 bytes here, and these other 2 would be left unused, and that's kind of a waste of space. So what you more likely want to use is a short. That way you're making more use of your memory. Now, I know with today's systems, with all the memory they have, it may not seem like that big of a deal, but I think it's best to try and be as efficient as you can whenever possible. So moving on to floats and doubles. So really the difference between floats and doubles is the memory they allocate. A float allocates 4 bytes and a double allocates 8. Both the float and the double are used to store numbers with decimal points, like 6.78. You'll want to try to use doubles as much as possible, and I know that sounds like it kind of contradicts what I just said previously, but the reason I say this is because by default Whenever C++ encounters a decimal point number, it assumes it's a double. And I'll show you guys examples of this when we do the coding portion. But if you were to store the value 6.78 into a float and then try to compare it to 6.78, C++ would say that they weren't equal because it's trying to compare a float to a double. And doubles are, in general, more precise and accurate than floats. So the last one we're going to kind of talk about here is a boolean, or bool. So when you declare a bool, C++ allocates 1 byte of memory. And bools are kind of strange or different compared to the rest of the ones we've talked today. And you'll see that when we start coding with it, but it's usually meant to evaluate things that would be true or false. And 0, if you assign a bool an integer value of 0, that evaluates to false, and any other number evaluates to true. And I'll show you guys examples of that when we do the coding. So let's talk a little bit about compatibility. So C++ is not as abstract as, say, Java. C++ has platform dependencies, and the amount of memory allocated for each type of variable is one of those platform dependencies. All the examples I've shown here should generally conform to most Windows systems. So what I mean by platform is your combination of hardware and software. And I know that Linux operating systems combined with different software allocate that space differently, and I know different Mac software or Mac OSs combined with different hardware allocate these differently. But the good news is it's very easy to find out. You just have to use the size of method, which I'll show you guys how to do in the next tutorial. So that kind of wraps up this little look into variable concepts. I hope you guys learned quite a bit from this. If this doesn't quite make sense to you yet, just kind of hang in there till the next one. I promise you it'll all click at some point during the next video. So just hang in there, and thanks for watching. I'll hopefully have the next video up within a week of releasing this video. So I hope to see you all again in the next video.